All right, so we're going to do another little chat about vector valued functions. Right now we're going to talk about when you're asked to find the total distance. So we know in non-parametric, non-vector valued functions, when we're asked to find total distance, it involves essentially either finding the distance traveled on each leg of a trip, making that distance a positive quantity because it's a distance, not a displacement, and then summing all those distances, or using an absolute value in a calculator when you integrate, a whole bunch of different ways that you can do it, but most of them involve finding when the particle is at rest. There's a pretty cool thing about finding total distance for a vector valued function, which is that total distance is actually just arc length. Because if you picture it, right, this function that we have, right, we have some like curvy function, right? And this curvy function is defined by an x of t and a y of t, right? And where its position is. So if you picture what r is, as r moves, it's just tracing this curve, right? That's the distance that this thing's going to cover. If this is where it starts at t equals 0 and it moves this way the whole time, then really finding the total distance it traveled is really just the same as finding arc length, which is dope because we're already really good at finding arc length. So we know how to find arc length in parametric. If you think back to the way we found arc length in parametric, right? In parametric, we started from, let's say, some t equals a to t equals b, and the way that we found our arc length was by integrating from a to b of the square root of x prime of t quantity squared plus y prime of t quantity squared. Right? And if you added a third dimension here and there was a z prime, it would be the same situation. Obviously, all of that's with respect to t. But here's the thing. It's the same for vector-valued functions as it is for the rest of parametric. So although it's treated as a different content, vector-valued functions are essentially parametric equations in a lot of ways with slightly different notation. So basically, arc length is the same as total distance for a vector-valued function. So if you're asked to find the total distance of a vector-valued function, you just do the parametric arc length formula, which is dope.